welcome to my channel and then coaching center. So today I'm going to explain your 12th standard physics 13 chapter, that is Nuclei part 2 part 1 video. So let's come to the chapter Nuclei. So we have learned about that in every atom the positive charge and the mass of the densely concerned. So nuclei is so, and also the radius of an atom by a factor of about 10⁴. This means that the volume of nucleus is about 10 to the power 12 times the volume of an atom. So atomic mass and composition of nucleus. So the mass of an atom is very small compared to kilogram. Therefore 1 u is equal to mass of the 112C atom by 12. So therefore 1.992647 10 to the power minus 26 into 26 kg. So therefore 1.660539 into 10 to the power minus 27 kg we get. So accurate measurement of the atomic mass is carried out with a mass spectrogram. So with a mass spectrometer we will find the accurate mass. And the measurement of an atomic mass reveals the existence of the atoms in that chemical properties. So here they have given a sum that consists of an example that two isotopes having masses 39.98 and 36.98 and and other two isotopes have 75.4 and 24.6%. So we have to find the average mass of the two isotopes. So let us do the multiplication of first these two and then we will do plus. So therefore we get this 34.47 u and electron in the mass of proton is equal to 1.00727 is equal to 1.67262 into 10 to the power minus 27 is the mass of the proton. We get. So discovery of neutron. So let us know how it is got. So but the masses of the nuclei of the hydrogen, deuterium and tritium are in the ratio of 1:2:3. Therefore the nuclei of the deuterium and tritium must contain, in addition to a proton, some neutral material. The amount of neutral material present in the nuclei of the isotopes. So the mass of the neutron is known to the high degree of the accuracy. It is Mn is equal to 1.00866 u is equal to 1.6749 into 10 to the power minus 27 kg. So Z is equal to atomic mass is equal to neutron number of proton. N is equal to neutron is equal to number of neutron number and number of neutron, and A minus mass number is equal to Z plus N. Total number of proton and neutron is the thing we get. So series of the nucleus. So Rutherford was the pioneer who postulated and established the existence of the atomic nucleus, and the Rutherford suggestion Geiger and Madsen performed this classical experiment on the scattering of a particle from the thin gold coins. Their experiment revealed that the distance of the closest approach to a gold nucleus of a particle of a kinetic energy 5.5 MeV is about 4.0 into 10 to the power minus 14 meter. They got, and therefore by that it has been found that the nucleus of mass A has a radius r is equal to r0 a by a root 1 by a to the power 1 by 3, and also mass energy of the nucleus binding energy, mass energy. So Einstein showed that the theory of the special relativity, that it is necessary to treat mass as another form of energy. Before the advent of this theory of special relativity, it was presumed that mass and energy were conserved separately in the reaction. So E is equal to mc square is the mass energy, is the Einstein mass energy equivalent relation, and light in the vacuum and is approached equally to the 3 into 10 to the power 8 meter square. So, and in the conservation of law of energy states that the final energy or equal to provide the energy associated with the mass is also included. So nuclear binding energy. So here mass of 8 neutron is equal to 8 into 1.008866 in U. Mass of 8 proton is so these proton numbers. here proton nuclear number, mass number. So therefore, thus the find the mass of the OA, O16 and 18. We have to use the formula delta M is equal to ZMP plus bracket A minus Z Mn minus M. This formula we have to use, and also since the mass of the oxygen of the nucleus is less than sum of the mass of the constituents, the equivalent energy of its consists with one. So they find that the energy required EO is related to the mass divided by EO delta mc square. So therefore the energy is called as the binding energy of the nucleus. It is called as the binding energy, and E and EO is the total energy of the nucleus, is equal supply of total energy. So let us know about the features of it. The binding energy. So the binding energy per nuclear is practical constant. They are constant, and the lower from both the light nuclei. They are lower than the lower for both light nuclei, lightweight nuclei, and heavyweight nuclei. They are lower. And some conclusion from the two observations that the force is attracted from sufficient strong to produce a binding energy, and the constant of the binding energy in the range 30 to 173 is a consequence of the short range. It is a consequence, and a very heavy nucleus has lower binding energy per nucleon. Thus if the nucleus 240 breaks into two, A is equal to 120, we get into 120 nucleus. And we should have to consider two very light nuclei joining to form a heavier nucleus. So light nuclei should join to form a heavier nucleus. So these are the observation we got. They may ask in your final exam. Remember this. Next is nuclear form. So electrons is familiar to Coulomb force. And there are obtained from the variety of experiments carried out during 1932 to 1950. So variety of experiments were carried out. There are the number of nuclear force is much stronger than the Coulomb force, acting between charges, or the gravitational force between the between the masses, and also the nuclear force between two nucleons falls rapidly to zero. Also they did. And the nuclear force between neuron and proton, proton and neuron, and proton and proton is appropriately the same way for that. And radioactivity. So while studying the flux and fluorescence and phosphorescence of compounds irradiating with visible light, the experiment performed substantially show that the radioactivity was the nuclear phenomena. It shows. So let us know about the three types of radioactivity decay occurred in the nature, that are A decay, in which the helium nucleus is emitted; P decay with proton with electron and proton; Y decay which high energy or energy photons are emitted, So law of radioactivity. So therefore here delta n by delta t and dn by dt is equal to minus lambda by n. Like that only we will put it and we will solve it. We will get r is equal to lambda n. So this is the formula of the law of radioactivity decay. So this you have to practice. So okay friends, till here you understand, I think so. So like my video, comment on video, and subscribe my channel and coaching center for more video. I will explain the next topic of this chapter in my next video. So okay friends, guys, you take care. I will see you in the next video. Till then, take care. Have a nice day. Like the video, comment on video, and subscribe my channel and coaching center for more video. Bye friends.